So when you look at this question, you're trying to find x. You see that x is underneath the radical and x is outside of the radical. So that means we have a radical equation because x is underneath the radical. And so we know we are going to go through our process of isolating the radical, raising, solving, and then checking. Now, when we talk about isolating the radical, the first step is that we need to get the radical on one side is equal to a number or an expression of some sort. But it should just be that the radical on one side is there and then everything else is on the other side. So when you look at your equal sign here and you look to the right of the equal sign, you do not just have one radical. So what we're going to do to start off this problem is get the radical by itself by adding x to both sides. Now, what that allows us to do is now we just have a square root on the right-hand side. And now that we just purely have one square root on the right-hand side, when we raise to the second power, the square root and the square will cancel each other out. Now, of course, if we raise on the left-hand side, we have to raise on the right-hand side. So that gives us 2x plus 15, again, the square root and the square cancel, equals, and then as we discussed in the last example, the square power cannot be distributed because of this plus sign. So what we have to do is we have to write out our two copies of x plus 6, and then FOIL that guy out. So that will give us x squared plus the 6x plus the 6x gives us 12x plus 36, and then the 2x plus 15. All right, so as we said before, we always want to look at the type of equation we have. So we initially started with a radical equation, we raised, and now we're at the solve step. And for the solve step, we're looking just at this equation here, and we're identifying that this is a quadratic equation because the highest power is 2. And so we will subtract 2x, subtract 15 as a starting point of moving everything over to one side. And so when we do that, we get 0 is equal to x squared plus 10x plus 21. Now, at this point, you kind of have two options. You can factor it if you like to factor, or you could do the quadratic formula. But because we have three terms, we can't really use the square root method. We've got to go into either factoring or quadratic formula. So factoring is going to be probably the easiest, most time-efficient thing to do here. So if you look at the first times the last, you would have 1 times 21. So you want two numbers that multiply together to give you 21, and they need to add to the middle. So we need to add to get 10. So working through that, the obvious choice is going to be 7 and 3, because multiply together get 21, add to get 10. Now, because of the fact that we have a 1x squared here, we get very excited about that because anytime we have a 1x squared, we do not have to split up the middle. We can just write it as x and then plop down the 3 and the 7. Now that it's factored, we set each of the factors equal to 0. And that gives us -7 and -3. Now, it's very tempting to think that this is it, that's the final answer. But anytime you have a square root question where the variable is underneath the radical, you isolate, you raise, you solve, but then there is this issue that when you square something, you're completely overlooking the sign. So whether it's a plus or a minus, when it's squared, you're going to get a positive. So because of that overlooking of the sign, we absolutely have to check these two solutions, proposed solutions, into the original equation. So what we do is we go back to the original equation, again, not the equation that we started to simplify and do other stuff with, but the original equation. And we simply plug in the x is equal to -7 and see if that checks out. So again, this x will get plugged in for -7, that x will get plugged in for -7. So we have 2 times -7 plus 15 minus this x gets plugged in for -7. Plug in, equals 6. All right, so here we have our -14 plus 15, so that gives us square root of 1, plus, because of the double negative, 7 is equal to 6. So that's checking out to give us 8 is equal to 6, which of course is false. And so that tells us that this -7 solution is our extraneous solution. It does not check out. Now, that doesn't necessarily mean that x is equal to -3 is going to work. You got to also check that to see if that truly will work out for us. So if I go up to the original and plug in -3, plug in, question, does this equal to 6? So I see that I have -6 plus 15, so I have the square root of 9 here. The double negative becomes a +3. Question, is that equal to 6? And yes, it is of course equal to 6. You got 3 plus 3 is equal to 6. So that tells you that -3 is the solution. And you know, there's not too many equations out there that we absolutely have to test. And I just want to say the two types of equations as far as the 1105 material that you absolutely must check, it's non-negotiable for this final exam. You have to check when the variable is inside that radical, and you also have to check when you have a logarithm of a variable equation. So those are the two biggies, when there's a square root and the variable is trapped inside the square root, or if the variable is inside the argument. And we'll talk about the argument situation later, but for now I just want to emphasize that those are the two types where you absolutely have to check.